Good afternoon, everyone. My name is Andrew Barker with BendixKing, Honeywell. It says booth A34, A36. That was my Sun and Fun slideshow, and I forgot to update it, so sorry about that. But we're not in booth A34, A36. If you go down the center, the flight line over here, we're just out here in the middle between A and B. So today we're going to talk a little about autopilots, autopilot technology in general, and then of course we'll do some Q&A and answer any questions you guys have. A little bit about me. Those of you that know me or know of me, I'm an autopilot nerd forever in the experimental and general aviation market. I'm pretty notorious for the cowboy hat and the long blonde hair, so that's kind of how everyone approaches me these days. Is, hey, where's the guy with the long hair and the cowboy hat? So I grew up in Springdale, Arkansas. That's in northwest Arkansas, ASG. Airport brat for my entire life. Got my PPL at 17. First Oshkosh in my airplane, or not my airplane, but the family 150 was in 1999, and I've been in Oshkosh basically every year of my life since 1982. So I got an RV4 and an RV10 that are my personal aircraft. The RV10 was actually the test bed that we used at TrueTrack to develop all the TrueTrack autopilots. I was the first employee hired at TrueTrack in the year 2000, and since then I kind of just did every job that was available. I kind of knew really early on that my long-term mission was going to be to own TrueTrack and to certify the autopilot, so I kind of set out on that goal. And when one of the first two partners of the company wanted to retire, I was fortunate enough to be able to leverage everything down to my socks and buy him out. And then the same thing with the remaining partner a few years later so that I could get into the certification. They had a lot of fun in the experimental world, and they were never really interested in certifying the autopilot. And I always said, well, Andrew, when you want to do that, that's your mission. Buy the company from us and go do that. So that kind of made that my mission for the last 15 years of my life. Got my Bachelor of Science in Mechanical Engineering from the University of Arkansas. That's right there in Fayetteville, where TrueTrack was based in Springdale. So very nearby. That was kind of home for me. Kind of already talked about the buyout and all that sort of good stuff. In July of 2017, we did get that autopilot certification. It was probably one of the happiest days of my life, honestly. Of course, I have two beautiful children, so those are the real happiest days. But as far as career-wise and aspiration to do something that had a positive impact in general aviation, that was kind of the pinnacle for me. Really, the ability to bring an affordable autopilot to the mass aviation community was really a lifelong dream. So we're super excited about that. After that, Honeywell came and said, we'd really like to have your autopilot and have you join the team. So I said, okay, let's make that happen. And we made that announcement in July at Oshkosh in 2019. So I've, much like most of you, I've been saying last year when I refer to 2019 Oshkosh. So 2 years ago, last year, I sold the Autopilot company to Honeywell and joined the team at Honeywell. And I've been working in the BendixKing group since then, working on general aviation strategy. I'm now Vice President of Sales at BendixKing in the Americas, but really do a lot of the strategy work there within BendixKing and Honeywell in general. So in autopilot technology, we really have kind of some norms that they're changing really quite rapidly. And I'm sure most of you know this because as you walk around here, you see essentially every major company has not only glass, but has an integrated autopilot built into that glass, or as a significant piece there of that glass. And when we talk about rate-based versus attitude-based autopilots, that's a kind of a legacy from the past, right? When we talk about rate-based, truthfully speaking, most autopilots today use rate as a significant portion of what they do. But traditionally speaking, what we're talking about is like a turn coordinator-based autopilot, which companies like S-Tech and Century made in the past. And then we've got attitude-based autopilots that are kind of more modern in what is typically done today. But there were also attitude autopilots in the past. Places like King Radio and Century both did an attitude-based autopilot, among others. But when we talk about rate-based, traditionally that was kind of viewed as a less capable autopilot. It couldn't fly quite as well in things like low speed because it's a turn coordinator-based system. It's twice as sensitive to azimuth rate as it is to roll. So when you get into low speed, it tends to want to hunt back and forth in what you would traditionally call a rate-based autopilot. Now in today's autopilots, it's a little bit different. When we're talking about the TrueTrack autopilot line, which is now the AeroCruise autopilot line at BendixKing, it is actually kind of a mixture of those two technologies. So we use rate a lot in the autopilot, mostly because we don't need to know attitude to fly an aircraft well because of the array of sensors we have access to these days at a very affordable cost. So it lets us kind of build a mix of that rate and attitude-based systems to give us the best of both worlds. We talk about gyros, right? Everyone knows about gyro is these days. We're all used to those rotating mass gyros. We shut the aircraft down, you hear it spin down. Now we've got solid-state rate gyros in everything that's being built. So you go from a rotating mass gyro that's very large, very heavy, to a solid-state rate gyro. And these really kind of started to come onto the scene in the late 1990s, early 2000s. Our early generations of autopilots at TrueTrack used what we thought was a solid-state rate gyro. It wasn't actually solid-state. It was like a vibrating bar within this gyro. So the gyro was about this large that we used in the early TrueTrack Autopilot days. Now the gyros that we used in the Autopilots are really no bigger than the end of this. So you've gone down drastically in size. You've also gone up drastically in capability and how good the gyro is, how good the signal is. The amount of drift that a solid-state rate gyro has today is orders of magnitude less than it did just 20 years ago. So we really capitalize heavily on that capability, not only in Autopilot technology, but again, all of these companies that are using these solid-state rate gyros really depend on that capability of them. So you've taken that rotating mass gyro out, which is heavy, expensive to maintain, and requires traditionally either a vacuum pump, of course, or an electrical system that can handle that. So really simplified the system by going to the solid-state rate gyros. Servo design, that's another kind of difference in Autopilot technologies. A lot of the Autopilots out there today actually use a position-based servo. At TrueTrack, we chose to use a velocity-based servo because it mixed really well with how we were doing our gyroscopics internally. It also let us build a servo that's much more simple than a lot of the other servos that are out there today. So personally, my preference is a velocity-based servo, but neither one of those is necessarily better or worse. We just use that velocity to our advantage. We let us make a servo, like I said, that's more simple because we didn't have to have a processor in it. The Autopilot can directly drive that servo, and then it doesn't have to care about position of the aircraft. We use the aircraft to close that feedback loop rather than using the position of the servo to do so. So we kind of almost turn the airplane into our position sensor. So why do we need autopilots? And I've got these three out here, and these three change position depending on the phase of flight you're in or what else is going on within the aircraft. So workload reduction. Obviously, it's really nice to have an autopilot. You need to fold a map. When things are busy, you're in busy airspace, something like that. You're getting vectored. It's really great. It's a second set of hands to fly the aircraft. Safety. It kind of works really closely with that workload reduction. It does improve the safety of the aircraft. The really great thing about modern autopilots is they basically all have this blue button that we all know, right? We push the blue button. What does it do? It gives us wings level and 0 vertical speed. So we can stabilize the aircraft in situations that, traditionally speaking, we weren't able to. An autopilot just 30 years ago wouldn't have had this capability, right? So you have a lot of pilots that maybe you're renting an aircraft, you're unfamiliar with the autopilot, so you're afraid to turn the autopilot on in a situation where it might be able to really help you out. So this is a place where a modern autopilot, with the safety it can provide, can really be a fantastic tool to help you in those situations. It doesn't have to be VFR to IMC situation where you would utilize that. I know a lot of customers have come by and talked to me and said, hey, I use the blue button a lot. I used it as a sales point to convince my wife, the CFO, that I needed this autopilot and that it was going to add all this safety. But what they really found was that they would use the blue button when they were in the pattern and they looked away and there was a cloud right there and they didn't even necessarily fly into the cloud, or maybe they're flying a practice approach. I had this one guy tell me that two pilots, two IFR, two instrument-rated, pilots flying the aircraft, and they were flying the approach, and they both got vertigo, and they were VMC. And they pushed the blue button, rolled the airplane wings level, they went around, they shot the mist, came back in, everything was great. He was convinced that without the blue button, it would have had a serious problem that day. And it's just a really, really great feature that is kind of the pinnacle for me of what modern autopilot technology can do. So comfort. Comfort's why you want the autopilot, right? So all of these reasons are why the FAA likes the autopilot. And they do like autopilots these days. I know that's a little different story than what we were used to in the 90s with autopilots, right? They were kind of things that they touched the controls, so they required ridiculous amounts of scrutiny. And I don't mean ridiculous in a negative way. They should require a lot of scrutiny. But modern autopilots have a lot of safety features built in, like I said, in the servos, that maybe make that a little bit different of a situation than it was even then. So when we get to the comfort side, that's why we like an autopilot, because we can sit there like this while we're flying. We become system managers, right? We can look at the map. We can, or follow along on our iPad, I guess, these days, right? Not look at a map, but we're working the radios. We're doing all these things. We're watching the engine. I find that I actually watch my engine data a lot more closely with an autopilot than I did without, because I'm not so focused on flying the aircraft all the time. I am still flying the aircraft. I'm managing that, but the autopilot's certainly providing some comfort there and making that job a little bit easier. So when we're talking about that comfort factor, it's another really important thing, even with a really basic autopilot. An autopilot, maybe it's just a wing leveler. Maybe you have a really basic wing leveler autopilot and a basic altitude hold. So that's going to get you about, in my opinion, 90% of the usefulness of an autopilot, because the other phases of flight are takeoff and landing. And so on a typical flight, if you're not having to hand fly all the way, and maybe your autopilot doesn't fly that coupled approach, but you're fresh when you get there to fly that approach. So you can hand fly that approach just like you've been flying for 10 minutes rather than 2.5 hours. So when we're selecting an autopilot for our aircraft, really one of the most important things that I usually ask is, what's your mission? How are you going to fly the aircraft? What are you going to do with it? What do you need your autopilot to do for you? Are you VFR, IFR? Are you training? What is your mission? Budget obviously is important to all of us. How much can we afford to spend on the technology we're putting in our aircraft? And then, of course, if we're talking certified aircraft, is there an STC? Can I actually purchase this product and put it in my aircraft? So, when you're talking about those situations, in a VFR situation, used to be that the best you could hope for was a roll axis or wing leveler autopilot. Now, essentially, every product out there today is at least a 2-axis autopilot. The majority have altitude select and the ability to follow GPS flight plans even. So the line's gotten very blurry between that VFR, IFR autopilot capability. Now it lies almost solely on whether it's capable of flying that coupled approach or not. Budget, autopilot budget is something that used to be at least 4 zeros on the check that we're writing there, and now you've got an autopilots that are much, much more affordable out there. A $20,000 autopilot a few years ago is less capable than 3 different companies' $6,000 autopilots are today. And these are safer autopilots with, like I said, more capability, more features, more interfaces, more integration with other things going on in the cockpit. On the certification side of it, obviously we're all driving for as many STCs as we can get. And I'm sure some of you here are going to ask about STCs later on, and that's a great question. I'll already tell you, yes, I love that question, and we're always driving for more. And so are our friends at Trio and Dynon, at Garmin, because we're interested in making the aviation industry safer. Of course, we want to sell your product as well. So capabilities of different autopilots. When we talk about a roll axis autopilot, traditionally, it's what we would call a wing leveler. We'll have a lot of customers come in and say, I've got a wing leveler. Unless you're talking about literally just a bank angle hold, it's actually a roll axis autopilot to autopilot nerds, because an autopilot has a roll axis is where you've got a direction selection capability, so either a heading or a track. Single axis versus multiple axis autopilots. Again, I kind of already touched on this just a little bit, but a single axis autopilot is either just a roll axis or just a pitch axis traditionally. Now we get into, in the experimental world, most autopilots there are 2-axis, so roll and pitch. And then in the certified world, a lot of aircraft do need a yaw damper, so we're at that 3rd axis in. Not very many aircraft on this field have the 4th axis, which would be auto throttle, but that's certainly an exciting area where I like to play some more. Analog versus digital autopilots. Analog autopilots were the way that all autopilots were done, essentially prior to the late 90s, early 2000s. We tend to speak negatively about analog autopilots like they're worse than digital autopilots, and that's not really actually true. An analog autopilot is really just as capable as a digital autopilot. The reason we make digital autopilots today is because they're easier to make and they're cheaper to manufacture. It's not that the technology is necessarily worse. Now, it does enable us to add more safety features that we couldn't with an analog autopilot, though. So that's certainly a benefit there of the digital. into a little bit of marketing stuff here. When we talk about GPSS, at least with my Autopilot, we talk about GPS steering versus GPS nav mode. GPS nav mode is when we're following a flight plan in a non-IFR navigator, so a handheld GPS. As it stands today, handheld GPS to me means any GPS that is an aviation GPS. It does not include, unfortunately, iPads and tablets, because right now there's not a company out there that makes an interface to convert the data that's produced there in the iPad or tablet using something like ForeFlight or something like that, and then sending it out to the Autopilot for a steering command. I do know there are a couple of companies that are working on that, and I'm very excited about that because I love the days of I can put a flight plan in my iPad and then push a button and have my Autopilot follow it. That's a really cool thing for me. So that's all what we call GPS nav. That's primarily a point-to-point navigation. When we talk about GPS steering, I'm sure some, or if not most of you know, that's going to come to us on the ARINC 429 bus, typically speaking, and it's a bank angle command that is sent to the Autopilot from either a GPS or from an FMS or from a PFD, MFD. So, again, something like a Garmin G3X or a Dynon HDX. Some of those things can provide GPS steering. We've also got Advanced that's capable of providing GPS steering as well. So then we get into the FMS systems. Obviously 430, 650, things like that all have lateral GPS steering, and many of those also have vertical GPS steering. VOR localizer ILS, so when we're talking about that VFR versus IFR mission, at BendixKing, for example, we have two different autopilots, the AeroCruise 100, which was the TrueTrack autopilot. It's a little less capable. It doesn't do coupled VOR localizer ILSs. When we talk about the KFC 230 or the AeroCruise 230, that's kind of a full-featured autopilot that can do VOR localizer ILS in addition to all those other features that we have in the AeroCruise 100. So that's typically today your big differentiator in autopilot product lines is whether it's going to fly a fully coupled approach rather than just a digital approach or something like that. RNAV and LPV approaches used to be a really big deal. Now in the Autopilot world, those are almost included in every offering there is. So when do we use an Autopilot? Typically, so as an Autopilot nerd, number one on this list, I will say that I have done that. I've actually turned the Autopilot on prior to rotation. I've turned the Autopilot on and let it actually land the aircraft. Now, that's when we're doing testing. Obviously, we're not going to do that if we're taking off IMC. We're going to get the climb going, at least get an established positive rate, get to a safe altitude before we engage the Autopilot. When we're doing FMS programming, even if we're on a VFR flight plan and we're just going out to, enjoy what we're seeing, we're still talking to ATC and we get direction changes, it's a great time to utilize our Autopilot. Let it do some of the work for you. High workload situations. When I'm in a Bravo airspace, the Autopilot is always flying the airplane. Maintaining Autopilot proficiency. If you're using your Autopilot in IMC regularly, please use the Autopilot, or if you're flying IMC regularly with an Autopilot, please do use your Autopilot regularly when you're flying your approaches. I personally like to hand fly my approaches, but I certainly make sure that I let the Autopilot do those every once in a while, not only because I'm testing it, but also because maintaining that proficiency and understanding that workflow of exactly what I'm going to do on the FMS and what I need to do on the Autopilot to make it fly that approach. Emergency situations. We already kind of talked about the blue button and how important I feel that is and how much safety it adds to the aircraft. Make sure you use your Autopilot in emergency situations. So that one's followed very, very closely by the next one. Know what your Autopilot's going to do. When you, in traditional Autopilots, I love the T6s. In traditional Autopilots, it's very difficult sometimes to understand what the Autopilot's going to do when I engage it. Turn on the Autopilot. If it's set to follow the heading bug, if the heading bug isn't set correctly, which way is the Autopilot going to go? And so I can understand the Autopilot hesitancy in those situations. So it's really important to know what your Autopilot's going to use so you can use it in that emergency situation. I kind of already touched on this, but it's a great pilot aid in those situations when you need to fold a map. Back in the day, when we used to fold maps, or take your hands off to eat a sandwich, or whatever. It's a great tool for those things as well. So we'll get in a little bit more into Autopilot modes and what each mode does in the Autopilot. So when we're talking in lateral modes, heading versus track, I know this is actually a big discussion again these days. I feel like I've been talking about heading versus track for the last 20 years of my life, and it's because I have been. When we started with the TrueTrack Autopilot, we elected not to put a heading bug capability in it. We put a track bug instead. This is because we said, well, if we had had the capability to follow track always, it is what we would have always chosen, because it's telling us where we're going, directly across the ground. The direction the nose is pointed is a byproduct of that. We don't really care where the nose is pointed unless we're maintaining runway heading and the aircraft next to us is flying heading, so that we don't drift into his lane or her lane, right? So that's the times when heading is important. Mostly is when other aircraft near you are flying on a heading. What I usually do is I'll maintain runway heading, and then I'll engage the autopilot and let it continue flying whatever track it needs to fly. If ATC gives me a heading to fly, I will put that in the autopilot, and I'll look at the compass and I'll say, oh, I need 5 more degrees, and so I roll 5 more degrees in. And if that still doesn't work, the same thing happens that always happens if you're flying a heading. Give me 5 more or give me 5 less. GPSS versus GPS nav, as far as an autopilot feature capability and what it really means is GPS nav is designed to be point-to-point location. GPS steering is designed to be kind of an entire course. GPS steering, you'll fly the curves and all that sort of good stuff. GPS nav, again, is that's point-to-point. It can be a multiple waypoint flight plan, but doesn't have to be that. It can be a direct to, and GPS steering is also used in a direct to. We don't turn those things on and off within the GPS. That's kind of almost a GPS-specific property. Vertical modes. Altitude hold and 0 vertical speed are some of my favorite discussions to have with customers, because 0 vertical speed is really underused in the autopilot community. If you're a VFR pilot and it's very, very turbulent, use 0 vertical speed because it's going to give you a better ride. Get yourself a block altitude if you can, and use that 0 vertical speed to give you a more comfortable ride. Because in altitude hold, we've got an altitude we're going to hold. The airplane gets pushed up or down due to turbulence. It's always trying to return back to that altitude. So you can get into more uncomfortable situations due to turbulence. And all the autopilots have either G limits or pitch rotation rate limits that try to limit that. But the reality is in turbulence, it is always working to get back to that altitude. Whereas if we're in 0 vertical speed, what it's going to do is stop the climb or stop the descent. And what you tend to find is that when you're flying cross-country in a situation like that, stopping the climb means that when the next bump comes, the airplane goes down and you stay really pretty close to the general altitude that you were after. Now, it's not going to hold at plus or minus 50 feet, but typically speaking, you're plus or minus 100 feet pretty easily, even in 0 vertical speed. Now, you may have to make some small adjustments when you see a trend. If it starts inching its way up or inching its way down, you bump in 100 feet up or 100 feet per minute down, something like that. When I fly through the mountains, it's typically in 0 vertical speed. Altitude select versus altitude pre-select. In a lot of nomenclature, these are used interchangeably. What it really means is in the autopilot is pre-select is we're going to input that prior to engaging the autopilot. So we're going to pre-select our altitude, and then when we engage the autopilot, it's going to climb or descend to that altitude. Hopefully, climb to, typically speaking, with a pre-select, it would be used on the ground. You've gotten a clearance to an altitude upon departure. We put that in so that we don't have to remember it. That's almost a feature that's becoming obsolete due to PFD, MFD systems, because we can set our altitude bugs there and then tell the autopilot to follow those later on. So you're kind of building pre-select into the EFIS screen there. Altitude select, of course, is set the altitude, tell the autopilot how to get there, and it does that transition, and then levels off and enters altitude hold automatically. In approach modes, I'm sure, again, most of you are familiar with this, but analog approaches, VOR localizer ILS. GPS approaches are those LPVs, LNAVs, LNAV plus V, and all of those are capabilities that we use GPS steering for in GPS approaches. To fly a true analog approaches, it does require an analog side to the autopilot, which is something that companies like TrueTrack and Trio, or now BendixKing and Trio and the AeroCruise 100, we don't do that analog side in our certified products. We did in some of our experimental stuff, but we made a decision not to go after the analog coupling market, partially because the autopilot was a little less, intentionally a little less capable system, but also because those, we tend to believe will actually eventually be phased out. I'm sure the timeline will continue increasing just like we've seen in the past, but eventually I do believe that analog approaches will kind of go by the way. GPS steering, this is a really, really neat thing for an autopilot. It almost takes kind of the outer loop of the autopilot and lets the GPS do it for us. GPS is going to compute this bank angle for the autopilot based on location, flight path, and ground speed, typically speaking. So that's how it computes our holds, and it actually adjusts the size of the hold based on your speed. And so it gives the autopilot some really smooth transitions. We can cut corners on waypoints and multiple waypoint flight plans and things like that. When we're talking about that, though, that is a GPS-based system. That is the GPS that's driving the autopilot through that. So as long as the autopilot's following that bank angle command, what it does is actually a GPS-based performance rather than autopilot-based performance. It does always require an IFR navigator. There is not a system out there other than some of the experimental EFIS systems. There are no GPS systems out there that provide GPS steering. It is a very precise way to fly an autopilot. We had a special project once we were working on that required extreme precision laterally. We were able to do it with standard GPS navigators off the shelf and the standard autopilot because it's such a nice, precise way to fly. It's kind of the modern way an autopilot follows a CDI rather than that analog deviation signal. Again, emergency modes. I like to talk about this a lot. It's a favorite subject of mine. Emergency level is not the only time when I think the autopilot's useful in emergency situations, but it is a really good one. When I was originally pitching the idea of the certification of the autopilot to the FAA and to EAA, who was our partner on that, I said, you know, what I really want to do with this autopilot is the same thing that Moving Map GPS did to CFIT, but I want to do it on purpose. And maybe some Garmin folks would tell me I'm wrong, and they did intentionally reduce CFIT accidents. But my intention with the certification of this autopilot was to remove LOC accidents, because the autopilot really should know most of those situations and help you out in those situations, or you should be using the autopilot more in those situations if we could keep the cost down enough so that the market penetration was high enough. So I actually just today got some really positive feedback from some sources on the accident data, and we are having a nice positive impact. Not we, TrueTrack or BendixKing, we the industry. So when we push that blue button, the autopilot goes to 0 bank and 0 vertical speed in this specific autopilot. In some of the other autopilots, it'll go to 0 bank and 0 pitch angle, or a +1 pitch angle, or something like that, again, to get the aircraft established in a safe attitude. What we'll also do in the AeroCruise 100 is a really neat feature that I really love. We'll go to that 0 bank and 0 vertical speed initially, and then we actually drop into the standard autopilot track mode, and we synchronize to the current track that the autopilot's flying. We do that because I found that when we simulated that VFR to IMC, we'd recover the aircraft, and of course it's not on the original course. So when we would do that recovery, we were usually between 45 and 90 degrees off by the time the aircraft was stabilized. So we'd say, okay, now what's the best way to get out of the trouble that we're in? If we're that inadvertent VFR to IMC, then I want a track selector immediately. I don't want to switch modes on the autopilot. I want the autopilot to kind of anticipate what my needs are going to be there. So we're going to say, okay, we're going to drop into track mode. It's going to synchronize, so it's not going to make any other changes until you tell it to, but we're going to synchronize to that track when we do that. So that you can figure out, okay, here's where you are, look at your iPad, look at your GPS, figure out where you are, figure out where you need to get, and you can make that change in direction. We actually did play with some of our initial software of putting in an automatic 180-degree feature or a pilot-initiated 180-degree feature. That's actually why we chose to not do that, is because of just some of the testing that we did. And I think that's kind of a personal preference thing. So bank angle protection mode, this is another feature that a lot of the companies out there have today. We have put it into this autopilot. It's one of the few autopilots on the market that does have a protection mode built in that can be easily activated or deactivated by the pilot. I used to, when I was talking about this feature, I used to always say, well, you could choose whether it be a Boeing or an Airbus captain to have a more automated or a less automated system. Those lines are really blurry now, so I can't use that joke anymore. But The zero bank, or excuse me, the bank angle protection mode is what we call AEP, and when the mode is in standby, it's monitoring the bank angle of the aircraft, and if the bank angle gets over 35 degrees of bank, it will automatically engage the roll servo and apply a corrective force into the control system. And what it's doing is driving the servo towards a 0 command, but as soon as it crosses through 30 degrees, it turns the autopilot servo back off. And the reason we do that is when we drive it at a very high velocity, and so it actually reduces the torque. It actually reduces the torque of the autopilot servo because we're commanding that super high velocity. Another time when that velocity drive servo, I can't compete with that. Another time when that velocity drive stepper motor servo is beneficial is because when we command those really high velocities, the servo actually loses some of its torque and some of its muscle. So it lets you really easily override that if you're intentionally flying that high bank angle, rather than having a system that you feel like you're maybe not fully in control of. Your tax dollars at work. Trim enunciation and control. So in a lot of the basic autopilots, the more entry-level autopilots in the certified world, we do trim enunciation. We don't do automatic pitch trim because it is a more expensive and more difficult feature to get certified, total honesty. In the experimental world, we do typically, I think every system out there does automatic pitch trim because it is easier for us to do in the experimental world. They all basically use the same trim system, whereas in the certified world, in a lot of cases, we have to do another servo, another installation, and it's kind of a separate product almost all unto its own. Important thing to know about trim is anytime we change airspeed, of course, that's when the autopilot expects you to trim. It doesn't have to be perfect. The autopilot has plenty of torque capability. There we go. The autopilot has plenty of torque capability, but one of the main reasons Am I safe? One of the main reasons that we do trim enunciation is because, like I said, when we're changing those airspeeds, they were going to get out of trim. We don't want you to disconnect the autopilot and have an unexpected pitch up or pitch down. Sure, of course, eventually you could run out of torque if you're commanding too much of a change from the current trim, but little changes really aren't a big deal. 100, 200 feet a minute either direction, the autopilot won't know the difference realistically. And I do a lot of times have I will have customers ask if it's going to hurt the servo. It doesn't hurt the servo to fly out of trim. It doesn't know the difference. It's using the same amount of muscle no matter what. It's really so that you don't run out of torque and so you don't get unexpected pitch changes. Control wheel steering is another one of my favorite features of the autopilot. I think they all are, but so when we use control wheel steering, it's kind of a two-feature button. It's mounted on the control stick. So we use that to, first, we serve as an emergency disconnect. So click the button, the autopilot disengages. We also use it if we fly it like I fly my RV4. So we push and hold the control wheel steering, roll to a 60-degree bank to where we want to be, roll back out, let go, and now we've synchronized to our new track and our new vertical speed. Typically, when we're doing that, it's back to 0 vertical speed, and then I'd go back to altitude hold if I wanted to do that. But it's also nice to establish a turn or a climb or something like that if you don't want to wait on the autopilot to do it. It's kind of a fun way to still use the autopilot and still manually fly all at the same time. So when I talked a little bit about integration already, we do integrate with a lot of different avionics out there, like heading bug and altitude bug from digital attitude sources. We don't require those digital attitude sources in the AeroCruise 100. In the AeroCruise 100, we don't require that digital attitude source, So we're literally only using the heading bug and altitude bug outputs from things like the Garmin G5 and the Aspen product line. We can get those heading bug, altitude bug from things like Dynon Skyview, as well as in the experimental world, essentially every product out there. We are working on AeroView Touch, XView Touch, and some other PFDs as well. So within the BendixKing product line, the last 16 months or so have made it a little more difficult for us to do some of those integration things we were hoping to do with the TrueTrack line in, but we're back working on those things now. So what we're doing at BendixKing right now, AeroView Touch is our PFD MFD product. It is now approved for over 350 aircraft models. We have interface for Aerocruise 230 that not coming this spring, it is coming this fall. That's a typo on my fault. Interface for the Aerocruise 100 is being worked right now. And then we're working on our XView Touch, which is our experimental offering. It'll have those same capabilities with the Aerocruise 100. We're also working to get engine monitoring and all that sort of good stuff built into there as well. The Aerocruise 100 Mooney certification is back underway. We did announce here at the show that that's a partnership we're working with Duncan Aviation. And the expectation there is that we'll have that STC completed in September. The FAA has been actually very complimentary of this process because it lets us kind of follow that same pathway we did at TrueTrack, but through this partner who's done a lot of other certifications, it's kind of a more familiar partnership there with the FAA. Not that we weren't familiar by the time we got finished, but it's a little bit, honestly, a little bit better relationship there. So FAA has accepted the cert plan. Ground testing is complete, and flight testing is scheduled here in the next couple of weeks. The Aerocruise 230 is approved now for most KFC 150 and KFC 200 retrofit installs. So we're approved for over 75 models there. In most cases, that installation cost that hardware cost is as low as $9,800. There are some situations where we do have to add some additional hardware that makes that a little bit more. Some are $12,000 to $13,000. One of the great things about the upgrade from the KFC 150-200 to the 230 is that you get an additional 2 years of warranty on your existing King servos there. I know those are very expensive servos to overhaul, so it's a great opportunity there. It does use the existing servos, brackets, and the majority of the wiring. We do have to change out the tray when we do that installation, but it is much less time consuming than, of course, a new Autopilot install would be.